Calculus for the Practical Man by Thompson. This is the book that Richard Feynman used to learn calculus, I'm told. And this is the second edition. This book is pretty hard to get. I'll try to leave a link in the description if I can find it. And it's a good book because it has answers. Let me show you. So this book has answers to the questions, right? So that makes it a great book for learning the answers to exercises and problems. That makes it a great book. The explanations are clean. It's intended for people who want to learn calculus on their own, I think. Calculus for the Practical Man by J.E. Thompson. Ooh, I gotta smell it. It smells so good. Just gotta give it a whiff here. Ah, so nice. D. Van Nostrand Company, Inc., Princeton, New Jersey. This book on simplified calculus is one of a series designed by the author and publisher for the reader with an interest in the meaning and simpler technique of mathematical science, and for those who wish to obtain a practical mastery of some of the more usual and directly useful branches of science without the aid of a teacher. Right. Like the other books in this series, it is the outgrowth of the author's experience with students such as those mentioned, and the demand experienced by the publisher for books which may be read as well as studied. So it's meant to be a book for self-study, which is why it says mathematics for self-study. So look at the contents. Fundamental ideas, rates and differentials, functions and derivatives, differentials of algebraic functions. On the page here. Use of rates and differentials in solving problems. Differentials of trigonometric functions. And then it says velocity, acceleration, and derivatives. Interpretation of functions and derivatives by means of graphs. That's very useful. Maximum and minimum values. Problems in maxima and minima. So just differential calculus, and then differentials of logarithmic and exponential functions. Still, we're on the topic of differential calculus. Give you a summary of differential formulas. Here we go. Reversing the process of differentiation. Enter the world of anti-differentiation. Integral formulas. How to use integral formulas. Interpretation of integrals by means of graphs. We have graphical applications of integration. Use of integrals in solving problems. The natural law of growth and the number. The law of growth in E. Yeah, that's cool. I was reading about that the other day in another book about the natural law of growth. Let's go to that. 287. I'm just curious because I was actually reading that just a few days ago in a newer book, a brand new book actually. The book by James Stewart. Introduction. In chapter 10, we have seen that a certain number designated by the symbol e is the number with which, when used as the base for logarithms, gives the simplest formula for the differential or derivative of a logarithm. Yes, it does. It's the natural choice because it makes the formula easy. And in chapter 11, we have seen that the integral of a reciprocal, which is the one exception to the general rule for integration of powers, furnishes a new definition of a logarithm, provided that e is used as the base. Yes, that is true. So it's just very interesting. See if we can jump into the math. Here we go. The rate of change is dA dt. Therefore, dA dt is equal to alpha times a. This equation states that the rate of change, dA dt, is proportional to the amount present. Very nice. I guess it's a, not alpha. I misspoke. Let me just go back and make sure that was an a, wasn't it? Yeah, it wasn't a. I said alpha, sorry. dA dt equals a alpha, or AA. It's a lowercase a and a big A. They should have used an alpha. The form of the equation which applies to either growth or decay can therefore be written a equals a sub 0 times e to the plus or minus at. And this states that in the natural law of growth or decay, the amount a of the substance or quantity undergoing change, which is present at any time t after the process starts, is an exponential function of the time with the original amount as the coefficient of the exponential. You'll notice that this reads very differently from newer books. The sentences are longer. So you're getting, even from the preface, the author writes, compound sentences. It's different. So it's written at a higher level than modern books. So, it's going to take your reading to a higher level, but the math itself is very simplistic. So it's kind of interesting because it's written correctly in a very good way, and the way books are supposed to be written. But today's books are they're a little bit simplified. They try to simplify the language. A lot of the older books, the English is just a little bit better, and just things are explained with more complex sentences. Here's a summary of differentiation formulas. Pretty cool. The function, the differential, and the derivative. Like how they do that. Yeah, here you get some more. Here's an easy one. Y equals x squared. The differential is dy equals 2x dx. And then we have dy dx equals 2x. So you notice you can just basically divide by dx and get that. So it's interesting. He gives you the differential notation and then the actual derivative. Differential notation is used a lot when you're doing integration by like substitution. That's when you would see differential notation. That's typically in Calculus 1. You study differentials and differential notation. Then you study integration by use substitution. And you use that because you'll let u equal 2x. And then so du is 2x dx, stuff like that. Really basic though. Really, really basic. It's a basic book. It's a book that if you're a student in college or a student in high school and you're taking calculus, like you could buy this and you can learn from it. I think it makes it extra cool. Show up to class with your book, mathematics for self-study, calculus for the practical man. It's just really fun. It's a really fun book. Probably should do some problems from this book and post them here on the channel. Do some more math problems, more calculus problems. Yeah. So I think the prereq for this book, by the way, is pretty much just some basic algebra. You're gonna need some really basic algebra, but you can probably jump into it even with just weak algebra skills, and your algebra skills will grow as you progress through the examples. As you can see here, this is going to test your algebra, right? Differentiate x plus y over x minus y. So they're using the quotient rule for derivatives. I memorized my quotient rule a little bit differently. I put the d. See how it says d of x plus y? That's the derivative of the top piece, x plus y. I put that first. So I do d of x plus y times x minus y minus the top. So everything is the same except I put that derivative first. That's just a slight difference in how I do it and how many other books do it. Many other books do it differently from me. I have a reason I do it the way I do it because it matches the product rule. Yeah, here we have another example. D of x over y. Taking the derivative of x over y. I gotta smell it again. I'm sorry. It's just emanating a beautiful smell. Wonderful. Yeah, anyways, Mathematics for Self-Study. Richard Feynman apparently used this book to teach himself some calculus. If you enjoyed this video, make sure to subscribe and like and comment and all the other stuff that I'm supposed to say. or not. This is a great book though, that I will say. Until next time, good luck and take care.